Second part of the lab. Find the fundamental frequency of a closed tube. Explain to your students that by using the calculated speed of sound from part 1, they'll be calculating the fundamental frequency, or the first resonating frequency, of a closed tube. Cap the inner tube on the end nearest the speaker. Slide the inner tube so that it is half of the initial measured length of the open tube. Have your students record this value in their chart. Calculate the fundamental frequency of the tube with your students using the equation F sub 1 is V over 4L, where L is the length of the closed tube, which is half the length of the original open tube, and N equals 1 because we're looking for the fundamental frequency. Have the students listen as you increase the frequency of the speaker starting from 0 Hz. Make sure they point out when the waves begin resonating. Once everyone agrees that the waves are resonating, again, the sound gets louder, have them record the frequency in the charts provided. This is the fundamental frequency. For your reference, the frequency should be around the value you calculated earlier. Discuss why this is true. We have the explanation later on in the calculations section. It may not match it exactly, but it should be very close. Record the frequency, the fundamental frequency, in the data table. Please click over here to see a video demonstration of the lab. Some warnings and tips. Do not set the amplitude of the sine wave generator too high, as the resulting sound may be very loud. Set the speaker at a 45-degree angle with respect to the tube opening instead of directly into the tube. And don't adjust the frequency too quickly, or you may miss a resonating frequency. We have two data tables. First is for part 1, trial 1 with the open tube, length of the open tube, the resonating frequency, and the calculated speed of sound. Then, take the calculated speed of sound from trial 1 and use that in trial 2. This will be our length of the closed tube, that's trial 2, calculated first resonating frequency, and then the first resonating frequency that we observe from the demonstration.